Alright, so we're looking at factoring trinomials where a is equal to 1. And most people's first question when they see that is, what on earth do you mean by a? Alright, so let's look at standard form of a trinomial. So a trinomial has an x squared term, the standard trinomial. It also has a x term, and it has some constant term. This is also our x to the 0 power. Here, I'm going to do that C in blue. Alright. So, the coefficient of the first term is referred to as A. The coefficient of the second term is referred to as B. And the constant term is referred to as C. Alright. Now, a standard form of a binomial, or a linear function, this is a quadratic function, because its highest exponent is 2. But for a linear function would be ax plus b. For a fourth degree term, it would actually be ax to the third plus bx to the second plus cx plus d. So the point is, a polynomial in standard form is written with its highest degree first, and its coefficients are usually represented with the earlier alphabetical letters going downwards. Alright, so let's erase that. So we're going to look at how to factor trinomials where this specifically is equal to 1. Alright, so let's take a look at a couple of examples. And remember, a trinomial is the product of its factors. So let's look at the factors first. Let's say x plus 3 times x plus 2. And if we use FOIL, we'll actually get x squared, because x times x is x squared. X times 2 is 2x, and x times 3 is 3x. If we combine those terms, we get 5x, and then 3 times 2, which is 6. So that's one example. Let's make up another one. X minus 3 times, I don't know, x plus 7. Okay. Again, it'll be x squared. X times 7 is 7x. Negative 3 times x is negative 3x. 7x minus 3x is equal to 4x. And then negative 3 times positive 7 is equal to negative 21. Alright, and one last one, just to get a good idea of some information here. Let's say x minus 5 and x plus, let's use a negative. That way we have a double positive example, a negative positive, and a negative negative. Negative, I don't know, 1. X times x is x squared. X times negative 1 is negative x. Negative 5 times x is negative 5x. We put those together, we get negative 6x. Negative 5 times negative 1 is positive 5. Alright, so what we're looking for here is a pattern that we can use. And what you might notice looking at this, or if you know this already, because I'm sure some of you have seen this before, that if we actually add the factors, they actually add up to the b term. Alright, so, and let's look at that. 3 plus 2 is 5. Negative 3 plus 7 is 4. Negative 5 plus negative 1 is negative 6. And that'll happen in all trinomials of this type. Alright? And another thing to notice is that the product of the factors is actually equal to the c term. 3 times 2 is 6. And then we have negative 3 times positive 7 is negative 21. And negative 5 times negative 1 is equal to positive 5. Again, this will be true for any trinomials. Let's look at another example. This is a weird one, so I figured we'd save it for last. So we have x minus 3 and x plus 3. That'll give us x times x, which is x squared. Negative 3, x times 3, which is 3x. Negative 3 times x, which is negative 3x. If you add those together, you actually get 0x, so I'm not going to write that in. And negative 3 times 3 is not negative 9. Alright? And if we actually add these two terms up, they add up to the middle term, which is 0x. So it even works in this case. These add up to 0x. And they multiply to be negative 9. Alright, so these patterns are what we use in order to help us factor these quickly and easily. Alright, so let's go to another slide and we'll take a look at another example. But instead of, this is just how we found our little pattern here. So our factors of these polynomials have to do two things. They have to multiply to be the c term and add up to be the b term. Alright? And don't forget that I'm saying the b term, I mean the x term, and when I'm saying the c term, I mean the constant term. Of course, it doesn't always have to be an x. It could be whatever variable we're working with. Let's take a look at an example. So factor the following completely. Let's make up something. X squared minus, I don't know, 10x plus 24. Alright, so we're looking for our factors here. They need to do two things. We need two terms that multiply to be 24 for here and here that also add up to be negative 10. Alright? So I like to make a chart or a table. Alright, so 24. What are the factors of 24? We got 1 and 24, 2 and 12, 3 and 8, 4 and 6, what else we got? Negative 1 and negative 24. These are the ones that people forget. Negative 2 and negative 12, negative 3 and negative 8, and negative 4 and negative 6. And then the question becomes, okay, we have 8 sets of factors. Well, which one are the correct factors? And the result is these add up to 25, so these are wrong. We need them to add up to negative 10. You'll also notice that all these positive factors are going to add up to positive numbers, but we need to get negative numbers, so it's got to be one of these. That's negative 25, negative 14, negative 11, and negative 10. Alright, so the idea is to get quick at spotting these, but you can also make a table with all the possibilities. So the factors here should be x minus 4 and x minus 6. And there's a couple ways you could check that that's right. One, you could just multiply these out and you should get what you started with. Another way would be to just substitute any number in place of x and see if they work out. So if this is 0, 0 minus 0 is 24. And then we have negative 4 times negative 6 equals 24. So these work. Alright? Now, some people wonder why we look at the factors of 24 first. Can't we look for numbers that add up to be negative 10 that multiply to be 24? Alright, let's take a look at what happens if we do that. Let's look at all the numbers that add up to be negative 10. Numbers that add up to be negative 10. Negative 5 and negative 5. Negative 6 and negative 4. Negative 7 and negative 3. Negative 8 and negative 2. Negative 9 and negative 1. Negative 10 and 0. Negative 11 and 1. I don't know if you noticed this, but this list is infinite. And if I were to actually try and find all the numbers that add up to be negative 10, I'd actually be going forever. And going on this list, this adds up, these multiply to be 24. These happen to be the correct factors, but this is an infinite list. That's not practical. We might as well do something that's practical. Finding the factors of 24 is a finite list, a non-infinite list, some short list we can use to help us find our answers. So let's do one more example, just to make sure it's clear. Alright, so let's change that to, let's change this to x squared plus 6x plus 7. Alright, so what are the factors of 7? We got 1. Oh, is this, did I do that right? No. Let's not do 7. Let's make that a 5. So, factors of 5. We got 1 and 5, negative 1 and negative 5, and I think that's it. And which one of those adds up to be 6? Well, this adds up to be negative 6. This one adds up to be positive 6. So the factors of this trinomial are x plus 1 and x plus 5. Again, you could check that by either FOILing this out, multiplying these, you'll get this. Or we could just substitute any number. I like to use 0, it's easy. 0 squared is 0 plus, this will be 0, should equal 5. And 0 plus 1 is 1. 0 plus 5 is 5. 1 times 5 is 5. So 5 and 5, they're equal. So these are the same. Alright. Now let's look at an example that can't be factored. Alright, so I'm going to erase this. An example that cannot be factored. X squared minus 3x plus, I should be able to make up any number and make this fail. Let's say 20. What are the factors of 20? Well, factors of 20 include 1 and 20, negative 1 and negative 20. I usually do the comparable ones first. Actually, I want to change this problem. Let's make this minus 20, or negative 20. What are the factors of negative 20? That's a more interesting list. We have negative 4 and 5, 4 and negative 5. So now one of them has to be positive and negative because this is negative. Alright, so we also have negative 10 and 2. We have 10 and negative 2. 1 and negative 20, and negative 1 and negative 20. And I believe those are the factors. So we're looking for a set of factors that actually add up to be negative 3. These add up to be positive 1. These add up to be negative 1, negative 8, positive 8, negative 19. That wasn't supposed to be here. This actually adds up to be 19, so none of them work. That means that this polynomial is unfactorable. Alright, so you most likely won't be asked to factor an unfactorable polynomial, but you might be asked to factor completely, and sometimes you can factor partially. Like sometimes you could take a GCF, you'll be left with a trinomial, and that trinomial will be unfactorable. Alright, so stay tuned for the next form of factoring.